So we start with a new topic called k-means clustering, so which is an unsupervised algorithm. So the definition of the k-means is an unsupervised clustering algorithm that partition k cluster by minimizing the variance with each cluster. So this is the definition of k-means clustering. So please have a look on this. So to understand the k-means clustering, let's take an example which is given as follows, right? So in step 1, let's consider in step 1. So there are certain points like P1 to P5, and each of these points has a coordinate x and y. So it consists of different value like P1 as 1, 1, P2 as 1.52, so 2 is y coordinate, P3 is 3, 4, P4 is 5 and 7, and P3 is 3.5 and 5. Okay. So we want to partition whatever the points or the tables given into k partition as 2. So that means the 2 clusters. Okay. Now coming to the step 2, right? We consider since 2 clusters are there, so let's select the 2 points which are initial centroids. So we are considering or assume the initial centroid for C1, that is the centroid 1 as 1, 1 for cluster 1, and centroid 2 as C2, that is 5 and 7. So which is nothing but 1, 1. So 1, 1 is your P1, okay, and 5 and 7. 5 and 7 is your P4. Okay. So sorry, this is not P2. So this is basically your P4. Okay. So 5 and 7. So 5 and 7, right? So this you have taken. So this is one centroid and P1 is another centroid. Clear? Now assign each points to the nearest centroid. So we do the Euclidean distance, right? Root over xa, xb and ya minus yb square, and root over of this x and y components. So how it looks like then? Do the same. So we already have P1, P2, P3, P5 and P4 and P5, correct? So distance to the centroid C1 will be your C11, and distance to C2, this is 5, 7. So we already assume that these are the 2 centroid, correct? So this C1 and C2, 5. So these 2, right? Now if we do the Euclidean distance P1 to the centroid C1, so obviously it will be 0, 0, correct? So like that P1 C2 centroid, correct? So this will be 1 minus 5, 1 minus 7, so that is 7.21. So similarly for P2 we find the Euclidean distance between the P2 C1, which is nothing but square root of 1.5 minus 1 square plus 2 minus 1 square, so which is actually 1.12. So similarly for the distance between the P2 and C1 is the square root of 1.5 minus 5 to minus 7 square, so this is coming 6.1. So for P3 so we compute the distance from centroid 1, P3 is coming 3.61. So similarly for P3 and C2 is coming 3.61. For P4 to centroid C1 it is 7.21, and D, that is the distance between the P4 and C2 is 0, 0. Okay. For P5 the distance of the Euclidean distance coming 4.71, and P5 to C2 is 2.5. Okay. So once it is done, so if you see these from the centroid 1, okay, P1, P2 and P3 whatever the value we are getting for these are very close. One, this. Okay. But if you see for the cluster 2, P4 and P5, so this form P4 and P5, so this value is kind of close to this cluster 2. So that means we need to compute a niche centroid for all these parts. Like let's say compute an niche centroid based upon this, because this P1, P2, P3 form a cluster 1 based upon this table. Okay, whereas P4 and P5 forms another cluster. So for this we need to find a new centroid. So how to find this new centroid? So if you see, to compute a new centroid C1, that is the mean of cluster 1, is nothing but my summation of 1, 1.5 and 3. So what is this 1, 1.5 and 3? So if you see, because we already make a cluster 1 for this, so this value is this one, 1, minus 5 and 3 for x. For y coordinate, what will be that? 1, 2 and 4. So 1, 2, no, 4 divided by 3, because there are 3 points out of that. So if we average, so we are getting 1.83 and 2.33. Now similarly for P4 and P5, we have to find a new centroid, so which is nothing but 5, 3 point. So this is my x coordinate, 5, 3.5, and for y coordinate is 7, that is 14. Okay, so 7, sorry, I think this is 5. Sorry. So this will be 5. Sorry for this correction. So this will be 5, correct? So, so 5, yeah, I think 3.5, 5 we are getting, yeah, I think it's correct. Yeah, fine. So, like that for C2, you also find a 4.25 and 6 as a new x and y coordinate. Now the question is that how we can do further steps. So the similar 3 and 4 steps, until it converges, we repeat the same procedure. Okay, and compute for the rest of the computation until it converges. So that is the condition. So the final cluster assigned will be as a kind of P1, P2, P3 as a centroid, this 1.83, 2.3 after computation, and for cluster we will get cluster 2 you get for P4 and P5 4.25 and 6. So since the centroid do not changes, once it is not changes, centroid will stop. Okay. Now step number 6. So what is the final objective? We are actually finding this sum square errors. So that is the objective function. So the objective function is defined as j is equal to I to the n, distance between pi. So pi is the points, cij, the cj is the centroid. So to kind of a partition or separate irrespective of the cluster 1 and cluster 2, the objective function j1 is defined as d of p1 c1 square plus d of p2 c1 square plus d, that is the distance between p3 c1 square. So this is nothing but the same thing, right, which we already computed here. Okay. So similarly for cluster 2 also we will find J2. So that is the objective function as the distance between the P4 and C2 plus distance between 5P, that is the point 5 and C2 square. So total sum of the square error is equal to J is equal to J1 plus J2. Okay. So what this AC measures? So AC measures how far the points in a cluster are from their cluster center or the center. So this is the condition. So that means K means tries to minimize the total square distance between each data point and the center of the cluster, which actually belongs to the sum of the square error, where if I define K1 to capital K, where xi is the xi belongs to that cluster, so xi are the individual component is irrespective of the mean to the square. So where k is the number of the cluster, ck is the set of the points in the cluster, xi is the data point or not data value, and μ is the mean of the cluster or centroid, where we find the square of the Euclidean distance between xi data point irrespective of the centroid or the mean of the cluster K. Hope this K means clustering is clear to everyone. So last one request is that whatever I have shown, irrespective of the K means clustering, irrespective of a example, please try to write a pseudocode algorithm for K means clustering, which actually give you a flavor, right, to understand the K means clustering, and further you can try to write a Python code to run this algorithm. Okay, so thank you very much, and also subscribe this video. Okay, bye bye.